Hello students, and welcome to our lesson on visualizing fractions. Now, because I said the word fraction, this is of course going to be everyone's favorite topic, and I understand that it's not, but that is okay. You do not have to feel bad. Pretty much every student I encounter will express that they do not like fractions, but in every instance I've found, it's just due to lack of understanding, not that there's anything actually wrong with the fractions themselves. So hopefully, between this lesson and the following lesson, we're going to get you a nice concrete foundation about how to understand fractions and work with them. That way you won't feel so negatively about them in the future. And if you already love fractions, then you're on the same page as me, and let's dive into this together. So fractions as parts of a whole, we're going to have two different ways to visualize fractions. First, we're going to talk about parts of a whole, and then at the end, we'll talk about ratios and rates. But first, parts of a whole, because this is the most common way to understand a fraction. So a fraction can represent part of a whole, where we divide a whole object into pieces. The top number of the fraction, which is called the numerator, tells how many parts we are including, and the bottom number of the fraction, which is called the denominator, tells us how many equal parts the whole is divided into. So for example, this bar down below is divided into 1, 2, 3, 4, 5, 6, 7, 8 equal pieces, and we have 1, 2, 3 of them that are shaded brown. So we would say that 3/8 of the chocolate bar are shaded. Okay, where again, the 8 on bottom represents how many equal pieces, all 8 of them we have, and the 3 on top represents the 1, 2, 3 pieces that are shaded. So parts of a whole just says how many parts are we including. So now, working with fractions, we have this thing called equivalent fractions, which will allow us to not only simplify fractions, but also find new fractions that can express different things for us. And we'll talk more about that when we get to rates. But for right now, we're going to be using equivalent fractions to just scale up or scale down our numerator and denominator, meaning we're going to make them either more complicated or less complicated. So how do we do it? Well, if we multiply or divide both the numerator and denominator by the same number, then we can create an equivalent fraction. And by equivalent fraction, I mean that it is a fraction that represents the same amount. So you can see the formulas we have here. If we start with a over b and we multiply a times n and b times n, so we multiply top and bottom by the same number, then the new fraction on the right will be equivalent to the fraction on the left. It will look different, but they will have the same value. We can also do this with division. If we take a over b and divide a by n and divide b by n, it will make the numbers smaller, but it will still be an equivalent fraction that represents, again, the same amount. Now, generally speaking, we multiply fractions, top and bottom, by the same number if we want to find a new representation for a specific purpose, but we divide fractions top and bottom by the same number to simplify fractions, which is what we're going to be doing the most in this course. So that is exactly the next bullet point. To simplify or reduce, if you prefer that word, I will use them both interchangeably. So to simplify or reduce a fraction, divide the numerator and denominator by their GCF. So remember, GCFs from a previous lesson is the greatest common factor. So when we look at the numerator and look at the denominator, we can find the greatest common factor between them and then divide both by that same number. We can also, instead of dividing by the GCF, we can do an equivalent approach, which is to find the prime factorization of both the numerator and denominator, and then simplify by canceling common factors from both top and bottom. So remember, factors are part of that prime factorization. We write the numerator and denominator each using their prime factors. And if we just cross off ones that match, we can get down to the simplified version of the fraction. That, however, though, that simplification by canceling is equivalent to just dividing by the GCF. So dividing by the GCF is easier as long as we know what that GCF is. All right, we're going to go both directions here. So 1, 2, and 3, we're going to make the fractions bigger or at least appear to have bigger numbers, even though they have the same value. And then 4 and 5, we're going to reduce or simplify the fractions. So number one, we want to write two equivalent fractions for 2/3. So what I'm going to do is take the fraction 2 over 3, and I'm going to multiply both top and bottom by whatever number I want. Okay, I can choose any number as long as I do the same thing on top and bottom. So I'm going to choose 2 as the first number I use. Now when I do this on top, 2 times 2 is going to give me 4. And on the bottom, 3 times 2 is going to give me 6. So I just showed that 2/3 is equivalent to 4 over 6 by multiplying both numerator and denominator by 2. Now it tells us to find two equivalent fractions, so we're going to do this again. We're going to start with 2 over 3, but then we can multiply top and bottom again by whatever we want. So I'm going to multiply by 100 this time. Okay. When I do 2 times 100 on top, I get 200, and 3 times 100 on bottom is 300. So now I've shown that 2 over 3 is equivalent to 200 over 300. Notice, by the way, that for both of these, if I do the opposite of what I just did, so if I divide the new fraction by what I multiplied earlier, it'll take me back to the original 2/3. All right, number 2. It says to rewrite 5 over 6 with a denominator of 18. So this is asking us essentially, what do we have to multiply by in the middle, and what will the new numerator be? So notice the setup I have. I'm writing 5 over 6, and then I'm leaving a little blank spot, and then is equal to something over 18, where we're trying to find out what I have to multiply top and bottom by in the middle here, and then what will this number on top become? So the way we find out what's multiplied by is we just check. What did 6 have to get multiplied by to turn into 18? Or in other words, what is 18 divided by 6? 18 divided by 6 is 3. So in the middle here, I had to multiply 6 by 3 to get to that 18. Now to keep the fraction equivalent, I'm going to do the same thing on top. So I'm going to multiply by 3. 5 times 3 up top is 15. And so 5 over 6 is equivalent to 15 over 18. Number 3, we're going to do the same thing, but with 4 over 7. So we're going to rewrite 4 over 7 with a denominator of 35. So I set the problem up the same way, where I have 4 over 7 and then a gap, and then something over 35. And then I just ask myself, what times 7 equals 35? Or what is 35 divided by 7? The answer is 5 times 7 equals 35. So I multiply top and bottom both by 5. 4 times 5 on top gives me 20. And so 4 over 7 is equivalent to 20 over 35. All right, now we're going to go the opposite direction. Number 4 says to simplify 18 over 24. So when we simplify a fraction, what we're going to do is divide top and bottom by some number. That number, though, if we want to get it fully simplified, needs to be the greatest common factor of the numerator and denominator. So when I look at number 4, I need to find out what is the GCF of 18 and 24. Remember that we can do this using prime factorization if we want. If we break down 18, it is 2 times 3 times 2. Or in other words, we have, oh, sorry, I said that backwards. 2 times 3 times 3. So it's 2 times 3 squared. And 24 is 4 times 6, which is 2 times 2 times 2 times 3. So when we put that all together, we end up with a GCF of 6. Okay, so I'm going to end up dividing top and bottom here, both by 6. And when I do that, 18 divided by 6 on top is 3, and 24 divided by 6 on bottom is 4. So now, you might be wondering, hey, you kind of said that stuff in a way I didn't follow. Well, it's because we're going to actually use prime factorization in the next problem, number 5. So for number 4, I wanted to show you that if the numbers are reasonable enough, you can just kind of think of the GCF and just try something. And if 6 wasn't the big enough number, okay, if there was still a common factor after we divided by 6, we would have seen a new fraction that we could reduce even farther. But because I was able to come up with 6 as a GCF, I just can go straight to it. But when you are in a case where you do not know what the GCF is, this is where you should use prime factorization. So for number 5, it says use prime factorization to simplify 42 over 56. So I'm going to break down 42 as being 2 times 21, and 21 is 3 times 7. Then I'm going to break down 56. 56 is 2 times 28. 28 is 2 times 14. And 14 is 2 times 7. So if I rewrite 42 over 56 using prime factorization, 42 is 2 times 3 times 7, and 56 is 2 times 2 times 2 times 7. Okay, now, instead of having to come up with the GCF just from thin air, I can actually just look at what factors they have in common, and that is the GCF. So notice that they both have a 2, so I can cross off a 2 from both lists, and they both have a 7, so I can cross off a 7, and all we're left with on top is a 3, and all we're left with on bottom is 2 times 2, so that's 4. So 42 over 56 reduces to just be 3 over 4, which happens to be the same thing that 18 over 24 reduced to, also 3 over 4. All right, but so now how is this the same as dividing by the GCF? Well, notice 2 times 7 is 14, and on the bottom, again, 2 times 7 is 14. So by crossing off those factors, what we actually did was divide top and bottom by 14. So 42 divided by 14 gives me 3, and 56 divided by 14 gives me 4. So by crossing off those factors, it is equivalent to dividing by that GCF, which in this case would have been 14. But notice that if I would have just divided by 14 from the beginning, then I don't have to do all the prime factorization steps. So those steps are there if you don't know what the GCF is, but if you know what the GCF is, notice how quick and easy number 4 looked. All right, moving on now to multiplying fractions. So we're going to have a lot of operations that we'll do with fractions. We're going to save addition and subtraction for the following lesson, but we do need to get down multiplication and division because quite honestly, they're the two simpler operations because we don't have to worry about the denominators. And we'll talk more about denominators in the next lesson. But so here, to multiply two fractions, multiply straight across. So we're going to multiply the numerator with the numerator and denominator with denominator. So a over b times c over d is a times c over b times d, where we're just multiplying straight across, top times top, bottom times bottom. So for these examples here, we can go pretty quickly through them. 2 over 5 times 3 over 4. 2 times 3 on top is 6. 5 times 4 on bottom is 20. And then we want to reduce any fraction that we get as a result. So we're done multiplying, but now we want to find an equivalent fraction that is simplified. So the GCF of 6 and 20 is going to be 2. So I'm now just going to divide top and bottom by 2. And that is going to give me an equivalent fraction of 3 over 10. And that is a fully simplified fraction now because 3 and 10 have a GCF of 1. Number 7, 7 over 8 times 2 over 3. 7 times 2 on top is 14. 8 times 3 on bottom is 24. Now notice 14 and 24 are both divisible by 2. So we're going to go ahead and just divide top and bottom both by 2. And that is going to leave us with 7 over 12. So 7 over 12 is the product of 7 over 8 and 2 over 3. Number 8, we have 5 over 6 times 9 over 10. This time I'm going to show you a little trick of how we can do the simplification before we multiply. So I'm going to zoom in on this one a bit. Before I actually multiply, I'm just going to rewrite each of these fractions using their prime factorization. And I'm actually going to write it below to make it clear which one is which. So 5 over 6, 5 is a prime number, so I'm going to leave it alone. But 6 is 2 times 3. Okay, so I rewrote 2 times 3 instead of 6. Then we're multiplying this by 9 over 10. 9 is 3 times 3, and 10 is 2 times 5. Okay, now when we multiply these fractions together, all the numbers on top are going to get multiplied together, and all the numbers on bottom will get multiplied together. So we could multiply across the top to get 45 and multiply across the bottom to get 60, but then I'm going to end up with, don't write this, 45 over 60, and then I'm stuck having to reduce that fraction. So instead of doing that, we can actually simplify first by just crossing off factors that the numerator and denominator have in common right now. So notice I see a 5 on top and a 5 on bottom, a 3 on top and a 3 on bottom, and then that's all it's going to cancel. So I am left with now on top just a 3, and on bottom 2 times 2 gives me 4. So I'm left with 3 over 4 as my result. Now let me just show you that if I had multiplied it out to be 45 over 60, 45 and 60 have a GCF of 15. So I would have divided top and bottom by 15, and that would have given me, again, 3 over 4. But it is much easier to simplify these fractions if you do the simplification before you multiply. And again, the reason I'm allowed to do that is that we were going to put these together to be all the numbers on top above all the numbers on bottom anyway. So instead of putting them together to get 45 on top and 60 on bottom, you can cancel out factors first and then make your life a little bit easier. So I recommend that you just don't do this step over here on the side and that you cancel out factors first and then go straight down to that answer of 3 over 4. All right, so multiplying fractions is done. Now we're going to talk about dividing fractions. But the thing is, dividing fractions is really the same thing as multiplying fractions, just with one extra step. So to divide fractions, instead, we will multiply the first fraction by the reciprocal of the second fraction. Reciprocal is just a fancy math term that means flip the fraction over. So flip the fraction. So the reciprocal of any fraction is just that same fraction, but upside down. All right, now multiply by the reciprocal. Some students don't really like to say that, even though it's technically the perfect way to describe it. So instead, you may have heard the phrase keep, change, flip, where keep, change, flip means exactly the same as multiply by the reciprocal. We're going to keep the first fraction the same. We're going to change the sign that's in the middle from division to multiplication. And then we're going to flip the second fraction because that is what reciprocal means. So instead of doing a over b divided by c over d, this is equivalent to a over b, where we left that the same, multiplied by d over c, where we change the sign and we flip the second fraction. We do the reciprocal of that second fraction. So division of fractions is just multiplication of fractions, but we have that extra step of having to flip the second fraction. So down for number 9, we have 3 over 4 divided by 2 over 5. Whenever you see division of fractions, step 1 is to just rewrite it as multiplication by the reciprocal. So 3 over 4 stays the same, but we're going to multiply by 5 over 2. And we can just go ahead and multiply straight across. This gives us 15 over 8. And the GCF of 15 and 8 is 1, so we do not have to simplify that fraction anymore. Number 10, we have 7 over 10 divided by 1/2. So we're going to multiply 7 over 10 by the reciprocal of 1/2, which is 2 over 1. When we multiply across the top and bottom, we're going to get 14 over 10, but we can make it a little bit easier on ourselves by, instead of multiplying right away, we can go ahead and cancel out factors that these numbers have in common. So this number 10 down here is actually 5 times 2. And so notice, after I write it as 5 times 2, I have a 2 on bottom that can cancel a 2 on top. So then when we multiply across the top and bottom, on top we just have 7. And on bottom we have 5 times 1, which is just 5. So we could have multiplied to get 14 over 10 and then reduced it to be 7 over 5. Or we can do that reduction first, where 10 on bottom is actually 5 over 2, cancel out those 2's, and then we just get 7 over 5. All right, number 11, I'm going to zoom in because it looks real small. We have 5 over 8 divided by 3 over 4. So when you have a fraction on top of a fraction like this, it tends to look very messy. So even more of a reason to rewrite it right away as 5 over 8. In this case, I'm going to write divided by 3 over 4 as the first step. However, you can skip that and just go straight to multiplying by the reciprocal. But I want to show you that this is the same. 5 over 8 on top is being divided by 3 over 4 on bottom. So now we're going to rewrite this as 5 over 8 multiplied by 4 over 3, where I do the reciprocal of that second fraction. Notice that the number 8 is actually 2 times 2 times 2, and the number 4 is actually 2 times 2. So we can cancel out 2 2's from the bottom and 2 2's from the top. So after doing that cancelization, we end up with just 5 on top and 2 times 3, which is 6 on bottom. If we didn't cancel out numbers in advance, we would have had 5 times 4, which is 20 on top, and 8 times 3, which is 24 on bottom. But 20 over 24 would then reduce to be 5 over 6, which is what we get by canceling out terms first. All right, so now a couple applications with this, and these are non-trivial in my opinion. So if these confuse you a bit, don't worry. I think these are hard for most people. Number 12 says a recipe calls for 2/3 of a chocolate bar. If you only have 1/2 of a chocolate bar left, what fraction of the needed amount do you have? And then I have a hint there, what you have divided by what you need. So when you're trying to figure out what fraction of the needed amount do you have, okay, this means to divide what you have by what you need. So all we have to do to solve this one is going to be to put what we have, which is 1/2, divided by what we need, which is 2 over 3. We can then rewrite this as 1/2 divided by 2 over 3. So exact same thing, just represented with the division symbol instead. We can then apply multiply by the reciprocal to do 1/2 multiplied by now 3 over 2. And then when we multiply across the top and across the bottom, we end up with 3/4. So to answer the question, what fraction of the needed amount do we have? We have 1/2 when we need 3/4. Sorry, we have 1/2 when we need 2/3. So 1/2 is 3/4 of 2/3. So we have 3/4 of the needed amount. Okay, so what we were really answering here is what fraction of 2/3 is 1/2. So we were trying to figure out what times 2/3 is 1/2. And the way we actually solve for the thing we're missing is by dividing 1/2 by 2/3. Now, the reason I'm not going too into detail about this statement here, what fraction of 2/3 is 1/2, is later in this class, we're going to use algebra to rewrite this as x times 2/3 equals 1/2, and then we will solve for x. But we don't quite have those skills yet. So for right now, we're thinking about it a little bit more generally as just take what you have and divide it by what you need. And that tells you the fraction of the needed amount that you have. Okay, number 13, you make a pan of 12 brownies to share with friends and family. Your family eats 1/3 of the pan, and then you share the remaining amount equally with 4 friends. What fraction of the whole pan does each friend get? So imagine real quick, if you will, that we have a rectangular pan of brownies, and we're going to divide this into 3 equal pieces. Now it says your family eats 1/3. So this third on the left is gone. Your family just ate that left rectangle. So that means that you have 2/3 remaining. So 2/3 of pan remaining. So now the actual question is asking us if that remaining amount is shared equally amongst 4 friends, what fraction of the whole pan does each friend get? So right now we have 2/3 of the pan, and we are going to split it evenly amongst 4 friends, meaning we're going to divide that 2/3 of a pan by 4 friends. This is the same as doing 2/3 multiplied by 1/4, because remember that a whole number, okay, this number 4 right here, is actually 4 over 1. We just don't write the denominator of 1 because it's unnecessary, okay? Otherwise, every whole number we would have to write over 1. So we're lazy, we don't do that. But really, a whole number is really that number over 1. So when you take the reciprocal, it becomes 1 over 4. Now, all we have to do is work out the multiplication. 2/3 times 1/4. We can go ahead and write this as 2 over 12. And because 2 and 12 have a GCF of 2, we can go ahead and divide top and bottom by 2 to get 1/6. Okay, so what we just found out is that each friend gets 1/6 of the pan. So 1/6 of the pan goes to each friend. So now, bonus question. If there was 12 brownies in the pan, how many brownies is 1/6 of a pan? So how many brownies does each friend get? Well, all we have to do is multiply 12 brownies times 1/6 is going to give me 12/6, which is 2 brownies per friend. So if you make 12 brownies, each friend gets 1/6 of those. That is 2 brownies per friend. All right, now we're going to change course a little bit. And instead of talking about fractions as parts of a whole, now we're going to talk about them as ratios and rates. Okay, so our first thing is a ratio, which compares two quantities. So for example, when I go to my local taco stand, they put 2 tortillas for every 1 taco. So we could say that the ratio is 2 to 1, where we write 2:1, or we can represent it as a fraction where it's 2 tortillas divided by 1 taco. So we have a ratio there of 2 tortillas to 1 taco. Okay, it's just a comparison between two quantities. If you give me 3 tacos, I know that each taco needs 2 tortillas, so that would require 6 tortillas. Okay, so it just tells you how to compare two quantities. A rate is very similar, but a rate is a special type of ratio that compares two quantities with different units. Okay, so specifically, we need the units to be different because then we're going to get this word per that shows up. So the word per represents the division. So for example, if $24 buys you 3 pounds of carne asada, we would say that the rate is $24 per 3 pounds of carne asada. So this division right here is this word per. Okay, so we can either say a fraction, $24 over 3 pounds, or we can write it in words, $24 per 3 pounds. So if you want to buy 3 pounds of carne asada, it's going to cost you $24. And then equivalent fractions are going to help us find equivalent ratios and rates to meet the needs of a situation. So we can already see that there's an equivalent fraction to 24/3, right? If we take 24/3 and divide top and bottom by 3, then this is going to reduce to be 8/1. And so that equivalent fraction is going to tell us that $8 will get us 1 pound of carne asada. Because if $24 got us 3 pounds and 8/1 is equivalent to 24/3, then that means that $8 is worth 1 pound of carne asada. So now we're going to do a couple manipulations with some numbers here. So in this table, we have that for 3 tacos, we need 6 tortillas, 3/4 or 3/4 pounds of carne asada, 1/6 cup of onions, and 1/8 cup of cilantro. Number 14 wants us to write the ratio of tortillas to tacos, then find an equivalent ratio to show how many tortillas are needed for 12 tacos. So the first thing we're going to do is just write down the ratio of tortillas to tacos. So from that table, we would say that 6 tortillas is going to give us 3 tacos. All right, just taking the 6 and the 3 from the table. But now we're going to use an equivalent ratio or an equivalent fraction here to make the denominator be 12 tacos. So if you remember from earlier problems, when we first did equivalent fractions, I'm writing the denominator down here, 12 tacos, and then I'm going to ask myself, what do I have to multiply 3 tacos by to get to 12 tacos? And the answer is 4. So I'll multiply the bottom by 4, and I'll do the same thing on top. 6 times 4 on top gives me 24 tortillas. So I then know that 12 tacos will require 24 tortillas. And I was able to do all that by just setting up an equivalent ratio. All right, number 15 is going to test our knowledge of fractions here a little bit. If you want to make 10 tacos, how much of each ingredient do you need? So the recipe up there is for 3 tacos. Notice that 10 is not divisible by 3. Okay, so the way we find out what we have to multiply each ingredient by is we take the ratio of the number of tacos the recipe makes and the number of tacos we want. Okay, so if we want 10 tacos, okay, we want 10 tacos, and the recipe makes 3, then that means that we need 10 thirds of the recipe. Okay, so notice all I had to do to get that fraction was take the amount we want and divide it by what the recipe already makes. So if we want 10 tacos and each recipe makes 3 tacos, then we need to make 10 thirds of the recipe. Now, real quick, notice that if we wanted 6 tacos, 6 is just 3 times 2. So we would have said that we want 6 tacos and the recipe makes 3. So our fraction would have been 6 over 3. But notice that 6 over 3 is just 2, right? 6 over 3 reduces to just be the number 2. So we would just be making double the recipe. Okay, it's a little bit less convenient looking when the fraction does not reduce to be a whole number, but it works just the same. We want 10 and the recipe makes 3, so we need to make 10 thirds of the recipe. So now we have this word of that's shown up a few times. So if I haven't pointed out cleanly yet, just know the word of means to multiply. So when we want to do 10 thirds of the recipe, that means to multiply 10 thirds by each element of the recipe. So what we're going to be doing is multiplying 10 thirds by the number of tortillas is 6. So 10 thirds by 6 is going to give us the tortillas. 10 thirds times 3 over 4 is going to give us the amount of carne asada. 10 thirds times 1 over 6 is going to give us the amount of onions. And let me shrink my writing here just a little bit so I can fit the last one. And our last one is going to be 10 thirds times 1 over 8 is going to give us the amount of cilantro. So now all we have to do is work out these multiplication problems. So 10 thirds times 6, remember 6 is really 6 over 1. Okay, so this is going to be 60 over 3 when we multiply it out. And if we do the division, 60 divided by 3 is equal to 20 tortillas. Now let's double check if that makes sense. We said earlier that we need 2 tortillas for every 1 taco. This ratio of 3 to 6 tells us every taco needs 2 tortillas. So if we want 10 tacos and each taco needs 2 tortillas, it makes sense that we need 20 tortillas. All right, so now we didn't set up that proportion or that ratio for every problem, but we did it for the tortillas. So 10 times 2 gives me that 20 tortillas that I need. Okay, working out the rest of these. We have 10 thirds times 3 over 4. So notice that the 3's on top and bottom can cancel each other out. And then 10 is actually 5 times 2. And 4 is 2 times 2. So I can go ahead and cancel one of those 2's also. So I know that looks a little messy, but all that is left is a 5 on top and a 2 on bottom. So I end up needing 5 over 2, and this is going to be pounds of carne asada. All right, and we're going to talk about mixed numbers in our next lesson. So for right now, we're just going to leave it as 5 over 2. No need to turn it into a mixed number. Last one, or sorry, not the last one, but next one, we have 10 over 3 times 1 over 6. Notice again that 10 is 5 times 2, and 6 is 3 times 2. So we can cross off a 2. And what we're left with on top is 5 times 1, which is 5. And on bottom, we have 3 times 3, which is 9. So we need 5/9, and this is going to be cups of onion. Okay, because we needed 1/6 for 3 tacos. We end up needing 5/9 cups of onion for 10 tacos. And then last one down there at the bottom, 10 over 3 times 1/8 for the cilantro. Notice again that 10 is 5 times 2, and 8 is 4 times 2. So if we cancel out one of these 2's, we end up on top with 5 times 1, and on bottom with 3 times 4, which is 12. So we need 5/12 cups of cilantro. All right, 2 more problems for us. Number 16 says carne asada is sold at a rate of $18 for 1.5 pounds. What is the price per pound? And then follow-up question, what is the cost to buy 4 pounds? So real quick, we need to look at this decimal 1.5 and turn it into a fraction. And this lesson is titled Visualizing Fractions. So let's draw a visual. Okay, 1.5 means that we have one whole of something, but then we also have another 0.5, and that is equivalent. Oh, that's a crazy looking sideways rectangle. That is equivalent, the extra 0.5 is 1/2 of a block. So we're going to have the whole top block, and then we're going to have half of the second block. So if we think about both of these rectangles as being 2 pieces each, we have 3 of the 4 pieces filled in, but 3 out of 4 would imply that one whole rectangle is 4 pieces, and that's not the case. One rectangle is 2 pieces, and we have 3 pieces filled in. So 1.5 is actually 3/2, where the number 3 is how many pieces we have, 1, 2, 3, and the number 2, remember the denominator, represents how many parts one whole is split into. So one whole is split into 2 pieces, not 4 pieces. So we have 3 out of 2 pieces. Okay, 3 pieces total, and each whole is 2 pieces, so 3/2. All right, so now we want to actually work out if $18 gets you 1.5 pounds, we can set up this rate of $18 over 3/2 pounds. And notice now we just have division by a fraction. So we can go ahead and rewrite this as 18 divided by 3/2, which is the same thing as 18 multiplied by 2/3. I multiply by the reciprocal. All right, and then I can go ahead and multiply straight across to get 36/3. And 36/3 just works out to be 12. So now that 12 has no units on it. So real quick, let's say what that 12 means. We started off with $18 for 3.5 pounds, and we ended up with just the number 12. Well, that number 12 is really 12/1. Okay, we're just usually too lazy to write that over 1. And so 12/1 is going to represent the exact same units as 18 over 3/2. Okay, 12/1 means $12 per 1 pound of carne asada. So we would say that the price per pound, okay, right here, 12/1, it's $12 per 1 pound of carne asada. So that is answer number 1, $12 per 1 pound. And then if we want to find out for question 2 there, what is the cost to buy 4 pounds? Okay, 4 pounds is just going to be our rate per 1 pound multiplied by 4. So 4 pounds is equal to $12 times 4. So this is going to be $48 for that 4 pounds of carne asada. Now, an equivalent way that we could have done that is very similar to number 14. We could have taken the ratio 18 divided by 3/2 and converted it to be 48/4. Okay, where we would have put 4 pounds on bottom and then found out what we need to multiply by in the middle. So whether we do it the way we did in 14, or we divide first to get 12, and then multiply 12 by 4, either way we end up in the same place. That 4 pounds is $48. All right, last question for us in this one. A taco truck makes 30 tacos in 1/4 hour. Write this as a rate, and then find out how many tacos can they make in 1 hour. So as a rate, we're going to write it as 30 tacos per 1/4 hour. And we can write this as a fraction. Equivalently, this is 30 tacos divided by 1/4 hour. Okay? And then if we want to find out how many they make in 1 hour, we need to multiply top and bottom by something. Okay, so we need to multiply by something on top and by something on bottom to come up with a number over 1 hour, where I need to turn this 1/4 into 1. So how do you turn 1/4 into 1? Well, 1/4 times 4 equals 1. So if I multiply top and bottom by 4, that'll give me 1 hour on bottom. And on top, 30 tacos times 4 is 120 tacos. So we end up with 120 tacos every 1 hour that this taco truck is working. All right, hopefully we were able to visualize some fractions in this one, and I'll see you in the next one for addition and subtraction of fractions.